All right. Well, this week we're going to talk about VPN technologies as discussed in Chapter 11 of your textbook. So, this week's learning objectives are going to be describing the fundamental functions of virtual private networks, the common VPN technologies, the elements of VPN implementation and management. The key concepts are going to be the difference between VPN and hardware-based VPN solutions, the protocols used for the secure remote access. We're going to talk about IPsec, SSL, and a few others out there. Uh, there are strategies for overcoming VPN performance and stability issues. And finally, we're going to talk about VPN virtualization. So, when it comes down to it, there's basically two different types of VPNs. And these categories can be split up, obviously, by the title of the slide, software and hardware solutions. So a software VPN is, something that's either sold as part of a operating system or as part of an appliance operating system or as a third-party software add-on. So these can be like on Microsoft Server, you have VPN services through routing and remote access in there. There's some that come in Azure in the cloud. There's some appliances like some TP-Link home routers and stuff, or some of the smaller home firewalls that have a built-in VPN service that you can enable. That software is there for to be enabled. Or you can have third-party like the NordVPN services, and there's others out there. Next, we also have the hardware VPN devices. These are standalone devices that are dedicated to managing VPN functions such as authentication, encapsulation, encryption, and filtering. And these are usually by your larger players like Cisco, Fortinet, Juniper, SonicWall. A lot of these will develop distinct and purposed only appliances that are dedicated to only doing VPN solutions. Okay. So, as we already touched on, an operating system based VPN, that's like an appliance that runs on Windows or a Unix operating system. They're kind of used in smaller to medium sized organizations. The benefit is, they're very inexpensive. They usually come with something that you already need and have. A lot of them are open source, and like you can find one there in your PF Sense out there. That's open sourced. You Some have potential security issues, like server communicates with the public network, generally the internet for the connection to occur. So first off, you have an exposed interface that's on the internet that could be compromised before the protections are enabled. I know it's a short period of time, but timing is everything. Next, we have module-based VPNs, and these kind of run as a component on a larger system. Uh, these can be a subset of something like on a firewall or a router that have just add the module like F5 load balancers. You can implement a VPN on those if you want to for just a couple things. One of the benefits of adding it, let's say, on a Palo Alto firewall or Checkpoint firewall or something of that matter, or a Cisco firewall. I'm going to try not to name their names because they are always changing them due to marketing, but these are brands that have been around. A lot of times that these will come in there, they usually just have a module component add-on fee. To enable the license, you just grab the licensing, you drop it on your system, and poof, that system is ready and rearing to be able to take on VPN client activity now. And then finally, we have dedicated hardware VPN solutions. These are dedicated to just being VPN servers. They're generally based on a router type platform, like Cisco has one, Fortinet has one, and there's a couple other large ones. Juniper is a one that has a solution that's out there, and they're very scalable because you can add more and more appliances, and they can interoperate as one solid entity out there. They can be deployed in a redundant manner, so you can load balance, you can fail over, um, and potential security issues like with any software or hardware device. There can be vulnerabilities in code on those appliances, so that's always something you got to be careful for. Uh, I know this is not timely, but of the week, first or second week of April, right before like April 13th, Palo Alto announced some issues with their uh, firewall and operating system, the Pan OS. They had some vulnerabilities in that will affect their VPN servers. And again, this is something that is in April 2024. So always be on the lookout for those changes. Now, you're going to hear the terms. Is it a layer 2 or layer 3 VPN? All right. So the protocols used by the majority of VPN solutions that work at layer 2 or layer 3 of the OSI model. If, as a reminder, layer 2 is the data link layer, and these are they protect uh, data transfers from one VPN endpoint to the other VPN endpoint. And some of these are like L2TP and its predecessor L2F. Okay. Um, what these do is they just kind of create it, encapsulate everything, and encrypt it, and then put it on the wire. Some don't even encrypt it. They just encapsulate it. They grab the whole packet, put it in there, and then encapsulate it within another packet as part of the data thing, and send it on the way. Now, we also have layer 3 of the OSI model. That is our network layer, if you don't remember. And this is responsible for the end-to-end packet delivery. Now, some of you are going, well, what is that? Well, if you remember IP of the TCP/IP thing, of the IP protocol, the IP protocol runs at the network layer. And this is going to be intuitive. That's why we have IPsec, Internet Protocol Security. And this communicates at the layer 3 layer. All right, so let's look at the IPsec protocol. Now, it's a standards-based protocol suite that's designed specifically for IP communications. There are several RFCs out there. If you ever go look at IEEE's request for comments, you can see several RFCs that talk about the different IPsec standards that are out there. As you can see, the concepts are that IPsec allows for authentication and encryption of each packet in an IP stream. So that's important because every packet has to be validated as part of this. So IPsec standard utilizes three major components. The first one being the authentication header. Then comes the encapsulating security payload, and that's where everything is stuffed in to the thing that's the encapsulation part where the unencrypted packet gets stuffed in there into the other packet. And then comes the internet key exchange, which allows for these to be have encryption enabled on them. So the authentication header, this also provides an integrity for the protection of the packet headers and data, as well as the user authentication. So it's important here, key concept, integrity protection, as well as user authentication. They can operationally provide replay protection and access protection because once these are encrypted, you're like, hey, I've already received this packet. The authentication bits have already been passed. One thing that people will know, and this might be a true-false question, it cannot encrypt any portion of a packet. So, can the AH header be used for encrypting a packet? False. All right, let's look at the encapsulating security payload. This can perform some authentication to provide integrity protection, although it's not for the outermost header. This is for inside the data stream. Okay. And that's where it is, and this is what keeps the data of the other packet inside that packet for it to go across the hostile network. And finally, we have the Internet Key Exchange. All right. The ITSY negotiates and creates and manages security associations, otherwise known as SAs. The SA is a set of values that define the IPsec features and protections for that connection to occur. So it's basically giving you the parameters of what cryptographical encryption methodology is going to be utilized for that VPN tunnel. And as we get into this, we can talk about the two types of transportation, or the way data is in motion. We'll say this. The two things are transport mode, which can be in a nutshell is host-to-host connectivity, and tunnel mode. This is where you have host to gateway or gateway to gateway. So like if you set up a system between two different systems on your network, let's say you have to have an IPsec connection for, let's say you're sending something between two servers that's very secret. You don't want anybody sniffing it. You can set up transport mode IPsec for yourself. You don't see it used that much, but there is some usage of it out there that can be used for that. The most common usage is tunnel mode. And this is where you have gateway to gateway. This is like maybe they'll set up an IPsec tunnel across the internet between two data centers or between a business and a vendor. They'll set up a VPN tunnel for that. And also if you're working remotely and you need to quote VPN into work, you're going to be using tunnel mode for a host to gateway connectivity there. So you're going to connect to that in a tunnel mode, and everything from your system, gateway to host or host to gateway, are going to be utilized that way. So you may say, well, that's not how we do it. I connect through a web browser, and I get like this little prompt, and then I can connect in, and then I see this stuff. Well, that's interesting because you know what? It's an alternative to IPsec as VPN. And this is called SSL VPN or Transport Layer Security, TLS. SSL has kind of been deprecated, and so more than likely people use the term SSL as just out of habit, but the connectivity is usually TLS 1.2 or 1.3 these days. All right, so this is where you like say HTTPS is the main thing. So if you ever go to like your banking website and you see that little lock in there, or you see HTTPS in there, you're gonna see that it is secured by a certificate that is secured with the public key. You're creating an encryption mechanism where you have the uh, you're encrypting with the public key and the server is decrypting with the private key. And your client can set up there, but it's still, out there on that. One thing is the client always authenticates into the server. So the server is the one that says, okay, client, who are you? And you have to prove who you are before I will let you in. And that's usually through the entering of your credentials or some other mechanism of multi-factor authentication that allow you in. If you do have what's called a certificate that can be issued to a client certificate, or sometimes if you have a badge that has a little looks like the back of a SIM card, or has a little key on there, a little circuit on there with some little things on there, and you have to put that in your computer. That's called a CAT card, and that's a client access card If any of you were in the military, you might have seen those being used, or if you were in any high-sec things, a lot of times you see that used. And they use a smart card reader with it. So these things can utilize a certificate that after you use your username and password, the certificate also is something you have versus the authentication mechanism of what you know. So who you are is your username, what you know is your password or passphrase, and your certificate, client certificate is something you have that can be in the form of a card or something like that. And that sets up that two-way uh, TLS certificate. Here's a good website, secure web browser using this. Krebs on Security. Great website to read about all the cool stuff going on in security. Brian Krebs is a great writer, and he can there be a great resource for you to learn on the fly with a lot of different things, current events, and security. So as you see up in the URL browser, you see it says HTTPS. To the left, you see a lock. A lot of new browsers have started deprecating that lock now, and they don't show it anymore because everything is defaulting to be more HTTPS nowadays. But if you always look in there, you'll see that. I think some of you in earlier labs were trying to figure out how to connect to the thing, and the browser was automatically adding HTTPS when you didn't specify HTTP colon, and your labs were failing. So if you put HTTP colon and then the IP address from your lab earlier, like in lab 3 or something, you would get it to work by that way. All right, so if you look at the lock, you can click on it and it'll bring up the certificate information. So here you see a certificate and it's issued by VeriSign, and this is a top level CA out there. And that CA is issued for, well, it looks like it's another 12 years. We're in 2024 now, so this will be out there till 2036. It'll be used for good. So, yep, we have a Class 3 VeriSign primary public cert, and that's somebody we trust. All right, so now we're talking about some SSL and TLS and VPNs. What are the benefits of these software type VPNs? Cheap. They're less expensive, of course, so we have less expensive VPNs. They're platform independent, so you can run them on a Mac, a Linux system, a Windows system. Doesn't matter the version. As long as you have a browser, you can use a lot of these type of VPNs. They allow flexibility for your clients, all of your things. So again, kind of like platform independence. If somebody rather have Microsoft Edge or something like Firefox or Google Chrome or Opera or whatever other browser that might be out there, they could utilize that. Uh, they also have no problems with NAT. So I don't know if you remember we covered it earlier, but IPsec sometimes has a problem with NAT unless the NAT has a special function on it. So yeah, you can go out there through a proxy server or anything like that, and out there. The VPNs that are SSL TLS, you can create a lot of granular controls through them and create portals out there. So if any of you ever connect into, let's say, Cougar Web or any of that, those type of portals, and you see your applications coming up, and you can click on, like, say, the library or say Canvas, you're actually connected through a TLS VPN. I bet you didn't even realize it. Another great thing about this is if you're publishing your VPN through a firewall, you'll only need to publish port 443 in the URL for that VPN. So it gets really easy to do that. Oh, last one, the fun one. SSH secure shell protocols. All right. These are on TCP port 22. Uh, you know, SSH V2 or V3 are usually the latest ones out there, versions. Um, it's a method for where the key is negotiated in the session, and you're asked to, create a key for that. So these were kind of created to replace, remote command prompts. A lot of times you used rlogon or telnet and a lot of Unix-based systems, and these kind of went by the wayside because A, they were in clear text and they weren't encrypted, and anybody sniffing the network could see you put in your username and password. And, once they got that, game over. Um, it's great for executing a command on a remote host or running a script on there. There's two ways to transfer files. One is SFTP or SCP is another one. So secure copy, SCP, secure copy. CP is copy command in Unix. SFTP is secure file transfer. Both of those operate with SSH. They can be used with rsync to kind of, copy and set up backup files and secure things and mirror security on different systems, mirror files between systems. You can set it up. You can use it with an open SSH server, and using that, you can create a VPN connection for that, like on the cheap. An example is use of PuTTY. That's a common one that's out there for free. It's a terminal emulation application, and it leverages SSH to provide connection to hosts. Another one I like to use is a application called Secure CRT. So those are two out there that can be used for creating SSH connections. All right, here's an example of what the PuTTY application looks like. And here you go, you put the IP address, and it's going to be on port 22. Just put the little radio button there for SSH. And close the window. And if you have a stored session or a saved key, you can load it there, and you'll get prompted to do that. PuTTY is a great little tool to use, and everyone should have it on their systems. All right, so let's take a shift, and now we've talked about the basics. Let's talk about performance and stability for VPNs. High performance can override stability. The use of stability can sometimes hinder performance. So you have that yin and yang going right now. So we'll break that down, and we'll talk about performance factors. So if we're trying to establish the performance factors, the stability factors for VPNs, first off, you're going to have to look at your VPN type. What are you going to be using your VPN for? Are you going to be using it to remotely publish applications? Are you using it for site to site? Are you using it to run commands? These are all different things you have to determine. And by that, you're going to have to look to see what protocol you're going to be using for that. And then you're going to have to take about how much load is going to be going across these systems. Is it going to be a lot of traffic? Is it going to be, should I use a lot more encryption on there? The use of a lot more encryption kind of brings down our performance. Lighter encryption is faster performance. You're going to have to talk about what clients you're going to configure. Is there a VPN client for the operating systems that I want to have connecting into the enterprise? How much bandwidth is the VPN going to be utilizing? That could be talking about the bandwidth for the corporate connection or for the client's connection. Is it going to just suck up all their bandwidth at their remote location, or is it going to be enough for other usage of their connection also? You're also going to have to determine your topology of that and how you're going to design your security VPN architecture. I already touched on encryption level when we were talking about the load up there. So yeah, higher encryption means slower performance. Traffic load is another thing, which is how many users are going to be using it. We're going to have a lot of users on it, or we're just going to have a few. And then you have to talk about the client versions out there. For the stability factors, you're going to have to talk about your configurations. Are we going to have a distributed solution among multiple data centers for redundancy in case of one goes down? Are we going to configure your multiple in an array per data center? For thing. Are we going to have some on the shelf that we can plug in if needed in case one of them goes down? What software version of the VPN are we going to use? And how often are we going to look to update it and keep it patched? And then are we going to look at the underlying operating system? Is it going to be a Windows OS kernel based out there? Or is it going to be a Linux-based kernel or BSD-based kernel? Or is it going to be a proprietary appliance-based kernel? These are a number of things you have to look at to understand, what stability factors that can be out there. Because there's certain operating systems, their underlying, core systems are fairly stable, but they all have some positive and negative points to them, which can affect that stability of them crashing. If you're ever on a Unix or Linux box and you get that famed kernel panic, uh, if you have a kernel panic after you have, let's say, 260 users on a VPN, then you're like, everyone goes down and it may take a while for that system to come back up. For Windows, the famed one is the blue screen of death. So we have different things. Also, you got to consider: are you going to be using your VPN with network address translations? So earlier I touched on this. So you can have conflicts between VPNs and network address translation. For those you don't know, network address translation is an internet standard that allows the use of a set of IPs on the internal LAN and a second set of IP addresses on the internet connection. If you look in your notes, I put RFC 19, I think 18 out there, which talks about all the private IP addressing in there. So you have addresses in the network range of 10.0.0.0/255 or /8. You have Class B private addresses, and those are 172.16 through 172.32, and those are /16 addresses. Those are your Class Bs. You can have anything in those ranges. And then, of course, you have the 192.168 range with the /24. And with that, you can have 255 subnets on that thing that would be considered private IP ranges. Now, all of those are non-routable on the internet, and those will allow you to NAT from these to something external. A reverse NAT is if you're publishing something on a private IP address, you provide a public IP address on your NATing device, which could be a firewall or a router or something else like maybe a load balancer. And when the traffic from the internet hits that public IP address, it converts the public IP address to the private IP address. It marks it in a table, and the return traffic from the private IP address on the way back out gets it replaced with the public IP address as the source packet. So that's kind of how it is for the way that works. In a nutshell, I put a video out there for you to watch on your own time about how NAT works. It explains it a lot better than I can using slides. So I hope you take a few minutes to watch that. It's kind of entertainment. It's really fun. That was also FYI trivia, and that was used to help address the dueling IP address spaces in IPv4. Now remember, there's two main types of NAT. The first one is static NAT, where there is a one-to-one relationship between an internal IP address and a public address on the NATing device. And then you have dynamic NAT, which is basically a pool of public addresses that are being used round robin or some other fashion for traffic on the external interface that have no mapping. Dynamic NAT is usually used for private IP addresses on the internal side, going to internet addresses on the external network. So IPsec has a major goof with it. Since, remember, we're talking about that authentication header port of that, that always had an issue with that because it says, hey, wait a second, we're changing the IP address of the original packet to something else. All right, so what they had to do is kind of create what is called NAT-T. And this is allowed for, it's NAT-T stands for NAT traversal for IPsec. And what they had to do was create an issue where they basically do a loop on the firewall where it does it and it kind of fools NAT basically into thinking the header is what it's supposed to be. So it goes in and out for that. For you to open a firewall rule that would allow this NAT-T and NAT traversal, you have to open up the ports for IKE at port 500. You have to allow that port to traverse over, and you have to allow IP protocol number 50. Now be aware, IP protocol 50 and IP protocol 51, these are not port numbers. These are protocol types. All right, your firewall will have what that is, and you'll understand that, they'll say either encapsulated security protocol. In the olden days, you had to create a complex definition for IP protocol number 50, which had certain attributes in there that allowed that type of packet to pass through your firewall. So now it's ESP is 50, AH is 51. GRE protocol was 53 or 50, IP protocol 51 or something, 52 or something for PPTP. So I can't remember what that was. So we had a lot of different ones, and protocol ports and protocol numbers are different. Now, there are things out there where you can have desktop virtualization and SSL virtualization, VPN virtualizations. So desktop virtualization is where you kind of see the desktop on another system. You can most likely see this with SSL VPNs or out there like that where you would just kind of like you connect in, it's like remote connectivity, and once you're connected, it brings up a desktop of where you're at. You have the SSL VPN virtualization, which is a portal like you see on Cougar Web where you see applications that would be public for you. So now we're going to talk about, or we already did talk about the difference between the software and hardware VPN solutions. We talk about the protocols used for secure remote access, IPsec VPN, SSL VPN, L2TP, PPTP, etc. We talked about how to overcome performance stability issues, and we also covered a little bit about VPN virtualization on one really awkward slide there. Well, thank you very much, and I'll see you in the next chapter.